Hi guys, Mr. Urrego here. Now, right now we're dividing. Okay, we're gonna be dividing complex numbers. Students will be able to divide complex numbers, same vocabulary, words. Okay, I had a build work, which is basically multiplying two complex numbers. All right, and let me solve one of them so I can show you what the conjugate is, because technically that's what we're going for. Okay, today, oh, I should put that on my vocabulary words as well. Today we're dividing complex numbers, and let me show you that so I can show you what the outcome. That's what we're doing, simplifying that expression, which is technically a fraction, irrational expression, and we call it division because 3 divided by 5 minus 4i. Now, in order to do this, I need to multiply by the conjugate. On my build work, I did 3 examples of multiplying 2 binomials, both binomials here, and 2 monomials right there. So the conjugate, let's multiply first. Okay, so I'm going to have here 2 minus 4i times 2 plus 4i. I'm going to solve that real quick. So I'm going to have 2 times 2, which is 4. 2 times 4i is 8i. That's an 8, by the way. Negative 4i times 2 is negative 8i. Oh my god, my numbers are horrible right now. I'm sorry. I gotta erase that. Okay, a little better. Now, negative 4i times negative 4i times 4i is negative 16i squared. Okay? If you notice, the i's in the middle are canceling out. 8i minus 8i cancel out, so I'm going to have 4 minus 16, and instead of the I squared, I'm going to write negative 1. Okay? I'm going to keep going. Let's kind of cross this out for a minute. So I got 4, negative 16 times negative 1 is positive 16, which is equal to 20. So if you notice, when I multiply those two, I'm not getting an I. I'm not getting an imaginary number. Those are canceling out. I'm just getting a real number. Okay? Keep that in mind. Let's do that number 2. Number 2, same thing as the first one. Okay? 5 times 5 is 25. 5 times negative 3i, negative 15i. Now the second term, 3i times 5, 15i. And 3i times the last one is negative 9i to the second power. Again, look at the middle terms, negative 15 plus 15. They are canceling out. So I'm going to have left 25 minus 9i squared. Instead of the I squared, times negative 1. 25, negative 9 times negative 1, positive 9, which is equal to 34. Again, no imaginary numbers, only a real number. So what's happening is the following. There's a pattern in here, okay, in these two problems. If you notice on the first and the second one, I have the same numbers, but the only change is the sign. I have 2 and I have 4i. 2 and 4i. The first one has a negative and the second one has a positive. So it's the same binomial but different signs. Look at the second one. 5, 5. 3i, 3i. What's the difference? The signs. Okay? So technically, I'm multiplying by the conjugate. The conjugate will be the second one. It's the first expression, but I only have to change the sign of the second one. It's the same as the first expression, but I'm changing the sign, and that's it. So that's called conjugate. I'm going to show you the definition so we can do division. I have some notes here, which is conjugate of a complex number a plus bi. So the conjugate of a complex number a plus bi, this is my original number, a plus bi. The conjugate will be a minus bi. So if you notice, I'm just changing the sign. Okay? If I have a positive, then I multiply by a negative. And the conjugate of, if I have a negative, I multiply by the positive. Same thing, but the positive. And one term over here, I'm sorry, one concept, very important, is that I'm not allowed to have an I on the denominator when I have a division or a fraction. Okay? So let me pull down an example so I can show you. All right, so number 1. If you see, I have 3 over 5 minus 4i, so I'm not able to have an I on the denominator. That's a no-no. So I got to multiply by the conjugate. The conjugate in this case is the same term, 5, let me put that in parentheses, 4i, but the only thing that I change is the sign. I have a negative, so my conjugate is positive. Whatever I do in the denominator, I got to multiply on the numerator. So I'm going to do the same thing on the top, 5 plus 4i. Okay? How come? Because 5 plus 4i divided by 5 plus 4i, I'm saying this numerator divided by this is equal to 1. And anything times 1 is the same thing. So technically, I'm not changing the expression. I'm multiplying times 1. All right? That's why the conjugate has to be the same thing on the top and the bottom. Okay? So there you go. Now I have two fractions. I have 3 over 5 minus 4i times 5 plus 4i over 5 plus 4i. So I'm going to multiply the 3 times the top. Let me change the color so we can see a little bit better. So 3 times 5 is going to give me 15. 3 times 4i is going to give me 12i over, okay? And that's distributive property basically. The bottom, I have two binomials, so I'm going to take the first one. 5 times 5, 25. 5 times 4i, 20. Okay? Negative 4i times 5, negative 20i. And negative 4 times 4i is negative 16i to the second power. Okay? So I just multiply. Make sure you multiply both terms, these two terms times the two terms on the inside. All right? Make sure. After that, I just simplify. So let me simplify. Equals, let's turn that into a purple. Equals the top. 15 plus 12i, nothing that I can do. They're not like terms, so I keep them both. 15 plus 12i. The bottom, 25. Nothing that I can combine it with. But let's look at the 20i minus 20i. As the same thing in the bell work, I'm sorry, in the problem sum from the top, these two are going to cancel. 20i minus 20i cancel out. And I have left negative 16i squared. Instead of the i squared, I'm going to write negative 1. Okay? Keep going. 15 plus 12i over negative 16 times negative 1 is going to be positive 16. So I have 25 plus 16, and I'm almost done. So the top, 15 plus 12i. The bottom, now they're like terms. 25 plus 16 is 41. And if you notice, there's no I on the denominator. You see at the beginning, I had a 4i right there. Now when I multiply times the conjugate, the i's are gone. I only have a 41, which is a real number. But now my answer, I had to write it in the form of a plus bi. That means that whenever I have a fraction, I need to break that into two little fractions. So I'm going to do 15 over 41 plus from the top 12 over 41, and my I will be at the end. And that's my final answer. Just notation wise, I have to organize it like this. Just for the notation, I have to organize it like that. A plus bi. Okay? I'm going to do one more problem and we move on. Second example, same thing. I have an I on the denominator. Not allowed to have an I on the denominator, so I got to get rid of that. Okay, technically this is called rationalizing the denominator. Rationalizing the denominator. We have to multiply times the conjugate. Okay, so here we go. So remember, is the denominator that I don't want the I on, so that's what I have to cancel. Therefore, my conjugate is the same thing, but instead of a positive, it's going to be a negative. Whatever I do in the denominator, I do in the numerator. It has to be the same on the top and the bottom. And now it's just a matter of multiplying. Okay, so let's start multiplying. Let's use red. 4 times 2, 8. 4 times negative 6i, negative 24i. I did the first term. Same thing with the 3. Negative 3i times 2 is negative 6i. Negative 3i times negative 6, positive 18i. Remember, I times I to the second power. Over bottom, 2 times 2, 4. 2 times negative 6, negative 12i. Okay, and second term, 6i times 2, 12i. 6i times negative 6i is negative 36i squared. Okay, doing great so far. Let's work on the top. 8, nothing to combine it with. Now let's look at those 24i and negative 6i. I gotta combine those two. So I'm gonna combine these two. Negative 24 minus 6 is negative 30i. Bring down the 18i squared instead of the I squared. Negative 1. All right? Now at the bottom, denominator. Over the bottom. 4. Look at the negative 12i plus 12i. They cancel out. You see, that's the reason I multiply my conjugate, to cancel the i's. What's left, I'm sorry, it's going to be negative 36i squared. Instead of the I squared, negative 1. Okay? Now it's just a matter of doing some math. Equals. This 18 times negative 1 is going to give negative 18. So let me write that down. So I'm going to have 8 minus 30i. Okay? 18 times negative 1, negative 18. Over negative 36 times negative 1 is positive 36. I'm going to have 4 plus 36. Let's finish. Equals the top. I'm able to combine that 8 with that negative 18. So 8 minus 18, negative 10. And bring down the negative 30i. Minus 30i. Over the bottom, 4 plus 36, 40. Okay? Am I done? No, I need to rewrite this in a plus bi form. Oh, I erased it already. Okay, a plus bi form. So if I have fractions, I got to break both of them. So this 40 divides the 10, and this 40 divides the negative 30. So I'm going to break it into 2, which is going to give me equals negative 10 over 40 minus 30 over 40. And at the end, I'm going to write my I, that I. Okay, technically I'm done, but if I can simplify the expression, I do it. So I can cancel 1 0 from the top, 1 0 from the bottom, which is going to give me negative 1 over 4 minus 1 0 from the top, 1 0 from the bottom, 3 over 4i. And that's my final answer. Remember, A plus bi. That's the form. Okay? Like I said over here, go to Classroom and work on complex numbers, dividing. Okay, we have 2 datas, one from yesterday, adding, subtracting, multiplying, and one from today, dividing. Those 2 have to be completed, please. All right, guys, have a beautiful day. Take care. Study.